Bismillahirrahmanirrahim. Subject is financial management, and this is 9th online lecture on capital budgeting technique. That is, we will discuss today internal rate of return in capital budgeting technique. This is one of the capital budgeting technique which is called internal rate of return. In today's lecture, we will discuss what is internal rate of return. As discussed briefly in earlier lecture, that is the rate which equates the initial cash outflow and present value of all cash inflows. So we will explain this internal rate of return with the help of example, which is numerical examples. Then we will discuss the solutions of the example or the question as we put in order to explain the internal rate of return. Then we will discuss what is the acceptance criteria of internal rate of return. Then we will discuss internal rate of return strength and weaknesses. So moving further, what is internal rate of return? Internal rate of return is, I mentioned earlier, that is, it is the discount rate. First of all, it is a discount rate. What is discount and compounding? When we calculate a present value of the future cash flow, then we use a discount rate. If we calculate or find future value of the cash flows, we call it compounded. So IRR is a discount rate that equates means at which present value of future net cash flow, from investment project with the project initial cash outflow, that becomes equal. So internal rate of return is a rate at which two things become equal. One is the present value of cash flow, future cash flow, is equal to what? Initial cash outflow. The rate at which these two things become equal, it is called IRR. The rate at which these two things become equal is called IRR. Now, mathematically, we can express it as equation like this. This is initial cash outflow, means of the project. That is, when the project is initiated, this cash flow will occur. It means the firm will invest this amount. This is cash flow of the future, and when it is discounted with a rate which is called internal rate of return for the first year, it will be a present value and will be comparable with the initial cash flow. This is cash flow of the second year. When it is discounted with IRR for the second year, then it will give present value of this cash flow. Similarly, that is the cash flow of the nth year. Nth year means any year, arbitrary year, which you may say 10th year, 50 years. So in maybe any number. So when we discounted it with the internal rate of return for nth year, then it will give present value of that cash flow. So at the rate at which these cash flow, present value of this cash flow equal to this initial cash outflow is called internal rate of return. Now we will discuss in examples, and we will explain the IRR calculation with the help of this example. Julie Miller is evaluating a new project for her firm's Basket Wonder. This Basket Wonder, BW, is the firm of Julie Miller. She determined that after-tax cash flow for the project will be 10,000 for the first year, 12,000 for the second, 15,000 for third year, $10,000 for 4th year and $7,000 for 5th year. Now the initial cash outlay will be $40,000. That is the amount that will be invested in order to undertake the project. This is called initial cash outlay, or ICO. How we will calculate internal rate of return? We will discuss it. In coming slides. IRR solution. First, we will use the same equation as discussed in earlier. This is 10,000. This is 12,000 cash in 2nd year. This is in 3rd year. This is 10,000 in 4th year. 7,000 in 5th year. We will discount these cash flow with the rate IR, or internal rate of return. But we don't know what is the rate at which these two future present value of this future cash flow is equal to this $40,000. We don't know. We will calculate it with the help of interpolation. What is interpolation? We will try hit and trial method. We will try different rate, and then we will calculate internal rate of return in between these two rates. Now, so find the interest rate or discount rate IRR that causes the discounted cash flow equal to 40,000. We will now try to find this IRR. So we will have to try one rate and then another rate. We oftenly in this interpolation method, one rate will give you a cash flow that will be less than 40,000. Let's suppose 37,000. Let's suppose maybe it give you $36,000, and there will be a rate which will give you cash flow maybe that is $42,000. So maybe it is very hard that you exactly guess that this discount rate will provide you a present value that will be exactly equal to 40,000. So in between these two rates, we will calculate internal rate of return. For example, first we are going to try 10% discount rate. Is it IRR, or IRR is less than or greater than 10%? So we will use table of present value. This is 40,000. We will calculate present value of 10,000 by putting present value interest factor for 10% in 1 year. That value will be comes from table. We will see for 10% and for 1 year, that is, let's suppose 1 year, in table present value single amount table, that will give you this amount. This is 12,000 cash flow. We will calculate present value of this 12,000 using 10% for 2 years. That factors comes from present value interest factor. Now 15,000 will be discounted for 10% for 3 years. This value will be get from present value interest factor single amount. This is 10,000 for the 4th. Present value interest factor for 4th year, 10% for 4 years. You will get this factor. 7,000, 10% for 5 year. We will get this factors. Now present value of 10,000 is $9,090. Present value of 12,000 second year extreme is $9,912. Present value of third year 15,000 is $11,265. Present value of 10,000 for the 4th year is $6,830. Present value of 7,000 for the 5th year is 5th year is $4,345. Now when we add these present value of the all cash flow, it becomes $41,444, which is not equal to 40,000. So it is greater than 40,000. It means we applied a very low rate, because when we apply a high rate we will get less amount, less present value. When we apply low rate we will get high present value. So that is reciprocal or in inverse relationship with the rate. This time we try 10% and 10% gave us the value, present value of all future cash flow, which is equal to $41,444. So we will apply a bit higher rate than 10%. Now we will try 15%. So 15%, this is the situation on 15%. This is 10,000 cash flow, and we will discount it with the present value interest factor of single amount for 15% 1 year. When we apply it, it gives us the factor that will be extracted from the table, present value table. So 10,000 multiplied by 870, we get 8,700 present value. 12,000 is discounted with the present value interest factor for 15% for second year, which gives the interest factor or discount factor as 0.756, which is we multiply with the 12,000, we get $9,072 present value. 15,000 cash flow is for the third year. It will be discounted with the present value interest factor 15% for 3 years, which gave us a factor of 0.658. When we multiplied 15,000 with 0.658, we get the present value as $9,870. This is the cash flow for fourth year, 10,000. It will be discounted with the present value interest factor for 15% for 4 years, which will give us the discount factor of 0.572, which is 5,720. Similarly, this is 7,000 for cash flow for the 5th year. In this amount is applied present value interest factor 15% for 5 years. That gave us this discount factor, which is multiplied with the 7,000, result that $3,479. Now when we add all these present value, it gives us the cumulative figure, which is 36,841, which is not equal to 40,000. So the rate is too high. Now we come to the conclusion that the rate is in between 10% and 15%. Because 15% gave us 36,000, 10% gave us 41,000 and some amount. So there is a rate in between 10 to 15, which is IRR, which will give us a present value of 40,000. So we trying to calculate this IRR. So the method used for this calculating this IRR is called interpolation. So IRR solution interpolation. What we will do, first of all, write 10%, then IRR, then 15%. The difference between 10% and IRR is unknown, which is denoted by X. The difference between 10% and 15%, these two, is 0.05. 5% difference exists between 10% and 15%. What we will do, we are trying to get the gap between 10% and IRR. We we will calculate this x. So x divided by 0.05. Now, till now, we discussed this dormant portion. Forget about it. In 10%, the present value of our future cash outflow is 41,444. We will write it. For 15%, we get the present value of our future cash flow is 36,841. This 15% gave us this value and 10% gave us this value. So IRR will give us exactly $40,000. Now the difference between these two is $1,444, and the difference between this 41 and 36 is $4,603. What we will do, we will divide this by this. So $1,444 divided by $4,603 will give us what? The whole situation will be like this. So for 1,444 divided by $4,603,000 multiplied by 0.05, which was here. So we multiplied it to the other sides. We get the value of x, that is 0.015 value. So now how we will calculate IRR. Now IRR is equal to, that is equal to this 10%, 0.10 plus this x. So IRR is equal to what? This 10% and then x value, which is equal to 0.1157 or 11.5%. So this is the rate which will equate all future cash inflows with the initial cash outflow. It is calculated through internal interpolation method. Oftenly we started from two rates, one is high and one is low, and then in between high and low we calculate the internal rate of return by this interpolation method. Once again, first of all, write these three things: the lower rate, the high rate, then IRR. In front of lower rate, write their present value of all future cash flow. IRR will give you exactly the amount that is equal to initial cash flow. 15% will give also you some value of present value of all future cash flow. So this will be written in two columns. The difference between lower rate and IRR is x, which is unknown. The difference between higher and lower rate, which is 5%. So x divided by 0.5. First we will do this step. X divided by 0.5 is equal to the difference between this initial cash outflow and higher present value is this one. The difference between lower and higher present value is this one. So divided this 1, 4, 4 and 4 divided by 4, 6, 0, 3. And finally we will, after solving, we will get this figure which will give you this amount 0.0157, which will be added to 10%, that will give you IRR. So IRR is the rate at which all future cash inflow will become equal to the initial cash outlay. What is the acceptance criteria? Every firms have its hurdle rate, or every firm have its required rate of return, that is set for accepting or rejecting the project, or set for calculating the present value of the project. So for the basket wonder, this hurdle rate is 13%. So this 13% is hurdle rate. If IRR is less than this, the criteria is, if IRR is less than any hurdle rate of the firm or required rate of the firm IRR, then we will reject the project. Should this project be separate, since its IRR is 11.5%, I guess, so it will not be accepted. So acceptance criteria is no. The firm will receive 11.5% for each dollar invested in the project, in this project, at a cost of 13%. So this is a required rate of return. IRR is less than hurdle rate, so the firm will reject the project. It will not accept it. What are the strength and weaknesses of the IRR? Strength of IRR is it's account for the basic concept, time value of money of finance. It uses time value of money. Second strength is it consider all cash flow. So third is very less subjective matter are involved, because this hurdle rate of 13% oftenly calculated by firms is weighted average cost of capital, WACC. This WACC have proper calculation methodology, so it is not subjective. Now what are the weaknesses? Weaknesses are it assumes all cash flow reinvested with IRR, which is not possible. Means this method developed with the assumption that all cash flow received by the firms are reinvested at the internal rate of return, which is not always the true picture of the project. When there is in ranking the project, we face difficulties in IRR, which we will discuss in a later lecture. If we get multiple IRR, if the cash flow pattern changes, we will get multiple IRR. In multiple IRR, we will face problems and decision making process. This is all about today's lecture. Thank you.